Today we're going to cover manufacturing in our lessons. Our unit, big idea for Unit 5. The design world is the product of a design process which provides ways to turn our resources, materials, tools and machines, people, information, energy, capital, and time into products and services. So our resources are materials, tools and machines, people, information, energy, capital, and time. Those resources are used to make the products and yield the services that we need. Our lesson big idea for lesson 2. Manufacturing technologies produce quality goods at low prices and apply the properties of materials to ensure the desired function of a product. Material properties. The physical properties of the material are a reason for selecting that material. You want to know what the performance of that product is going to yield. It's going to be based on the behavior and types of properties of the material that it's made of. For example, a material could have really good electrical conductivity properties, but it would perform poorly in maximum strength. So, a compromise or a trade off among the properties must be made. There's the trade off word again. We have had um, criteria and constraints when we talked about that, and you may have trade offs to maximize your usage of materials. So, often a compromise or a trade off among the needed properties must be made. You want to be consistent with the processing that you're selecting throughout your entire project and the structural state that is desired or possible. Please make sure that you're following along with safety standards so that you won't have a disaster like we saw last week with the Hyatt Hotel. Materials can be classified as the following: metals, ceramics, plastics, semiconductors, and composites. Now, I'll repeat, all materials are going to go into metals, ceramic, plastics, semiconductors, or composites. For metals, they're materials that are normally combinations of metallic elements. Elements will be combined. Their electrons are non-localized, So, consequently, you have generic types of properties. Metals are good conductors of heat and electricity. They're strong but malleable. They're luxurious when polished. Examples of metals: copper, aluminum, and titanium. And the example of copper, you'll see oxidation on copper when you see it on tops of buildings. You may see them on government buildings. There's a beautiful church that's being built over by NC State's campus, and that dome is copper. You can have on top of bay windows copper, but the oxidation of the wind, whatever the wind's blowing through, pollen, the water, all of that is happening, and you'll see instead of that bright copper, you'll see a dirty looking material. It is still providing the function it should provide, but the aesthetics are no longer there. Now, ceramics. They're compounds between metal and non metallic elements. They include things like oxides, nitrides, and carbides. So you're going to get a combination of oxygen, nitrogen, and carbon. They're insulating and they're resistant to high temperatures and harsh environments. I think of ceramics like resistors, high temperatures. Examples are clay, tungsten carbide, alumina, not aluminum, alumina, and glass. Please remember that glass is a ceramic. Plastics and polymers. They're organic compounds that's based upon the carbon and hydrogen that is in them. They have large molecular structures. They're low density, but they're not stable at high temperatures. Two types of plastics and polymers. You have thermoset. Thermoset plastics and polymers can be melted and shaped once. Thermoplastic can be melted and reshaped. So I guess it's easier to say thermoset because you're melted and the way you're shaped, that's the way you're set. It cannot be changed. Thermoplastic, you can be melted. They can go back and reshape it. So you've got something that was one way, you go back and melt it again and change it. Examples: nylon, polyester, and rubber, like the rack there. Semiconductors. The electrical properties. They're intermediate between, so they're between metallic conductors and ceramic insulators. The electrical properties are usually strong. They do have some small amount of impurities, but very good electrical properties normally. Examples are silicon and germanium. Composites. Composites consist of one or more. Composites consist of more than one distinct material, like fiberglass, a combination of glass and a polymer, concrete for your driveways, plywood. Those are composites. Now, what I'd like you to do is to take a few minutes and think about where you're sitting. What types of materials are surrounding you? Now, if you look at your computer or your cell phone, is it made of more than one type of material? Yes, because it's different components. Your monitor screen is made of one kind of material. The outside frame of the monitor is made of something else. Your computer's made of a different metal. So you've got metal, you've got polymers, you've got glass, you've got rubber cords coming out of it. Several types of materials go into making up a component. Now we're looking at properties of materials. The properties of materials have a classification of 5 items as well: mechanical, electrical, magnetic, optical and dielectric, and thermal. I'll repeat those material properties. Mechanical and electrical, magnetic, optical, and dielectric, and thermal is the final property. Now for mechanical properties, and you're going to want to refer back as you're doing your activities to the PowerPoint presentation. For tensile strength, you're going to be measuring the resistance of being pulled apart. So if you've got something there, you want to see how much strength does it take to pull it apart. That's your tensile strength. Your fracture toughness, the ability of a material containing a crack to resist fracture. Your fracture toughness. And I think of a driveway. They will frequently crack. That's why you will see them they'll take a diamond blade and they will cut lines in that concrete for a reason, and it's to help it not to fracture as much. Your fatigue strength, the ability of a material to resist various types of rapidly changing stresses. Creep strength, the ability of a material, of a metal, to withstand a constant weight or force at elevated temperatures. The creep strength would be more when you think of being in the desert versus being here, although it's hot here. Our temperatures are not normally as hot as being in the desert. The hardness, the property of a material to resist permanent indentation. So how hard is it? If you sit and you push against it with another material, how likely is it to have a dent? Electrical properties. You look at the conductivity and the resistivity. The conductivity is measuring how well a material accommodates the movement of an electrical charge. The resistivity is the opposition of a material to the flow of an electrical current. So this is when we talked about resistors. We looked at the current. We wanted to know what would happen if you had a resistance of 10 ohms compared to 20 ohms. The magnetic properties. The magnetic susceptibility is the ratio of your magnetism to your magnetic field. The Curie temperature is the temperature at which a material loses magnetism. So materials will act differently if you have them at certain temperatures. If you think of the Arctic, either the North Pole or the South Pole, extremely low temperatures compared to here in the U.S. and North Carolina. Saturation magnetism, the state reached when an increase in applied external magnetizing field cannot increase the magnetism of the material anymore. Now, when you think of magnetic fields, you have a magnetic field yet is small around your telephone. Thermal properties. Now we're looking at thermal, heat. The coefficient of thermal expansion, how much a material will expand for each degree of temperature increase. Next, we're looking at heat capacity, the amount of heat required to change a material's temperature by a given amount. Thermal conductivity. It indicates a material's ability to conduct heat. Now, when we look at manufacturing, we want to know, how do we apply the properties of materials? You have engineers and scientists using the material properties to select appropriate materials for product production. So, the scientist is going to tell you what you're going to be doing, where these materials are going to be used, and the engineer is going to go back and look at all the chemical properties of that particular product that he's suggesting is used and determine which product will be used based on its properties, and remember, trade-off. The manufacturing processes. The primary process is you're turning raw materials into standard stock. So we're looking at timber, going out in the woods, cutting down timber. The timber's cut first into boards. The secondary process, you're going to turn standard stock into finished products. The boards are turned into furniture, desk, chairs. The manufacturing types. There are 3 types of manufacturing. The final manufactured products will be one of these 3 types. They'll be custom, they'll be batch, or they're continuous. Now, if you're looking at custom manufacturing, one type that is made by a specialist, you can have examples of a yacht. A yacht will have some symbolism of a boat, but you're going to make extra stuff. It's going to be customized for that particular person. Clothing. When you have clothes that are special made for you, I don't know how much that's done on a regular basis. I know it gets expensive because they're hand picked. You're picking the material for your shirts, your skirts, your jackets, and then it's going to be hand stitched for you. I think that would be great if I could afford that, because clothes on the market now just aren't that well made. A purse, custom manufacturing. I could think of, well, I know Coach does purses. And MK, I think, is that Michael Kors? I'm not sure. All these brand names. It doesn't make sense to me to spend that much on things. But I'm also not wealthy. Batch manufacturing. Products that are made in batches. The components of a product are completed at a workstation before they're moved to the next one. Examples: bakery items, like the bagels that we see on the screen. You'll have paints. You'll have special edition shoes. Now, the batch manufacturing of the shoes that come out for these different athletes, it is a batch process instead of a customized process, because you do so much at one station, you move it to the next station, you move it to the next station, but they're not custom made for one person. They're made by size. So they all look alike, just a different size. Continuous manufacturing. Products are made with no interruption to the production line from input to output. Examples are cars, food products, and bricks. And the example you could think of is a production line for a car. So much is done at this station, Then after that station completes, then it's moved to the next station and it's built up some more there. Then it's moved to the next station with more product buildup. Interchangeable parts. Now, when we look at interchangeable parts, the invention of interchangeable parts was done in the 1700s. It increased manufacturing. Now we have innovative ideas that are coming forward. Interchangeable parts are parts that are identical, meaning to replace the original part. You do not have to make a custom piece. There's already one the same size available. The interchangeability of parts increase the effectiveness of all manufacturing processes. An example is a windshield wiper blade that can be used on multiple vehicle models. So parts that can be interchanged. Another example, brake shoes, brake pads. Another example, shocks and struts. That concludes our presentation on manufacturing. Any questions, guys? Thank you.